Radar is not about seeing everything. It's about seeing first. The U.S. Navy's SPY-6 radar system is built around that principle. Detect threats earlier, track them more accurately, and survive in an environment saturated with missiles and electronic interference. At its core, SPY-6 replaces older radar systems with scalable radar module assemblies powered by gallium nitride, GaN. And that material shift changes the physics. Traditional naval radars relied heavily on gallium arsenide. GaN allows higher power density and improved thermal efficiency. In simple terms, it can transmit stronger radar signals while handling more heat. Stronger signal out means stronger echo back. That increases detection range and sensitivity. But SPY-6 is not one giant radar face. It is modular. Each radar module assembly acts like a building block. Multiple modules combine to form a scalable radar array. Add more modules, and detection performance increases. This design allows installation on different ship classes, from destroyers to future platforms, without redesigning the entire system. More modules mean more transmitted power. More power means longer detection distances. But power introduces limits. Radar performance is governed by the radar equation. Detection range increases with transmitted power, antenna gain, and signal processing efficiency. But only to a point. Atmospheric conditions, curvature of the Earth, and target radar cross-section impose physical ceilings. You cannot detect beyond the horizon without elevated sensors. And the more power you transmit, the more heat you generate. GaN improves thermal handling, but naval ships still have finite cooling capacity. Destroyers must distribute electrical load between propulsion, weapons, sensors, and onboard systems. SPY-6 draws significant power. That introduces the first constraint: energy management. Modern warships are floating power grids. If radar output increases, electrical systems must compensate. Cooling systems must dissipate heat. Thermal buildup degrades performance and component lifespan. Detection is not just about signal strength. It is about sustained operation. SPY-6 is designed to track simultaneous air-breathing threats and ballistic missiles. That requires advanced signal processing and discrimination capability. Separating real threats from clutter, debris, and electronic interference is a computational challenge. Signal processing becomes the second constraint. As tracking complexity increases, processing demands rise. Data throughput expands. Real-time filtering and classification become more demanding. And then comes electronic warfare. Adversaries attempt to jam radar frequencies or flood systems with false returns. SPY-6 must adapt frequency bands, adjust power output, and maintain track integrity under interference. GaN modules help by providing stronger signal generation and better resistance to electronic attack. But jamming physics remains a constant battle. Radar cross-section is also evolving. Modern stealth aircraft reduce reflected radar energy. Hypersonic glide vehicles present high-speed, low-altitude detection challenges. Sea-skimming cruise missiles approach at low angles, limiting reaction time. SPY-6 improves detection capability, but it does not eliminate geometry. Earth's curvature still blocks low-flying objects beyond line of sight. Ship elevation still limits horizon distance. Detection distance buys time. Time buys response. But time is finite. Every radar system exists within a triangle of constraints: power, heat, and geometry. Increased power and cooling strain rises. Increased sensitivity and processing load expands. Expand tracking range and you collide with the horizon. SPY-6 represents a leap forward because its modular GaN architecture increases output and flexibility without requiring entirely new ship designs. But it remains bound by the same equations that have governed radar since its invention. Electromagnetic waves propagate according to fixed laws. Reflection depends on target shape and material. Signal strength decays with distance. No radar sees infinitely. SPY-6 simply pushes the threshold further. And in naval warfare, pushing detection range even slightly can determine whether interception happens at 100 miles or 50. That difference is survival, because radar dominance is not about perfect vision. It is about who sees first.